Assalamualaikum and hi everyone. Hope you are in a good state. We are from RCDCS 1434D.
We will be discussing our group project MAT272, which is an introduction to mechanics. So, let's first introduce each person in our group.
My name is Nurul Zakira binti Zainuddin and my matrix number is 2022878248.
Hi everyone, Assalamualaikum. My name is Nazril Fariduddin bin Zaidi and my matrix number is 2022486814.
Hi, Assalamualaikum everyone. My name is Kaisarana Anika binti Abdurrahman and my matrix number is 2022872106. Nice to meet you.
Assalamualaikum and greetings to everyone. My name is Salsabila Nuraisha. My matrix number 2022848988. Nice to meet you.
Hi, my name is Khairun Naja binti Rahmat Fauzi and my matrix number is 2022849696. So today we will be explaining to you guys regarding the Newton's law. There are three of them and each one of them is very similar yet very different to each other. So let's go.
So, now I'm going to explain about Newton's first law of motion. It states that an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion will stay in motion at the same speed and in the same direction unless acted on by an unbalanced force. This law, also called as law of inertia. As you can see, the animation here actually gives some picture about what I'm going to explain about. But let's dive into this law with another example. Here we have a ball that rolling on a curved track. Initially, the ball is actually at rest and not moving on the top of curved track. As the Newton's first law of motion states, an object will stay at rest unless acted on by an unbalanced force. So, we have here gravity act as the unbalanced force that eventually causes the ball to move. Then, when the ball reaches the flat surface, as we can see on the diagram, the ball now has a constant velocity and will keep moving just as the law stated. An object will stay in motion unless acted on by an unbalanced force brings it to stop. Examples for unbalanced force here can be frictions, gravity, and etc. But if it is in a vacuum space or any frictionless conditions, the ball will moving indefinitely. Now, let's understand more with the involvement of numbers. We have a situation where two persons kicking ball towards each other back and forth. Okay, assuming the only force acting on the ball is the frictional force. So, calculate the magnitude of the frictional force acting on the ball. First, we identify the variables. Find a velocity v equal to 0 since the ball will be stopped after being kicked. Next, the initial velocity u. Let's say it is 3 meters per second. The distance between the two persons is 4 meters. And lastly, the ball's weight is 0.5 kg. Find the acceleration using the formula v squared equal to u squared plus 2es. Then we got e equal to negative 9 over e. Negative here is because the ball decelerates before being stopped by another person. Lastly, to get the frictional force, we use the formula F equal to me. We plug in the values we obtained and we got F equal to 9 over 16 where approximately 0.5625 Newton. Therefore, according to this law, an external force which is unbalanced force here is needed to stop the ball. So in this case, the force is approximately 0.5625 Newton, causing the ball to decelerate and finally stop.
Moving on to the second, which is Newton's second law of motion, states that an object's acceleration by a force is inversely proportional to the mass of the object and directly proportional to the force. Well, according to Newton's second law definition, an object's acceleration is determined by its mass and the net force that is acting upon it. The ball's acceleration has an inverse relationship with its mass and directly proportional to the net force imposed on it. This indicates that an object's acceleration increases in proportion to the force acting against it. Similarly, an object's acceleration decreases with increasing mass. So now, I will show you this video as an example of Newton's second law taken from Japanese animation series called Demon Slayer or Kimetsu no Yaiba in Japanese version. So now you guys have already seen the video. So according to the image I show you here, you can see that a man by the name of Tanjiro is pushing a big rock over a sandy open area, demonstrating Newton's second law. The man's force overcomes the resistance and frictional force created by the rock's mass, causing it to move in the opposite direction. The rock accelerates at a rate that is directly proportionate to the force that he delivers. But the rock's mass has the opposite effect on its acceleration, so it moves more slowly than it would if it were lighter. Newton's second law is embodied in this scenario, which shows how the rock's acceleration is dependent on both its mass and the applied force.
So I'm gonna explain about this second example of Newton's second law. Here you can see a club hit a golf ball. What Newton's second law apply here? Okay, you can see that the force from the club makes the ball accelerate in the opposite direction to the swing. Okay, the ball's acceleration depends on how hard the golfer hits it and how heavy the ball is. Okay, this is the factors. So the impact of the clubs overcome any resistance like friction between the club and the ball, okay, sending the ball flying forward. So, factors like club's angle and how well the golfer strikes the ball also affect how far and where it goes. So, we can see that the club's force determines the ball acceleration and distance. So, you can see that force is equal to mass and times with acceleration.
Moving on onto the Newton's third law. Now, Newton's third law states for every action there is an equal but opposite reaction. We will understand more as we go through two examples that we provided. So, for the first example, we have the process of launching a rocket into the space. The principle of Newton's third law is crucial in understanding the mechanics of launching a rocket. When a rocket is launched, the engines will burn fuels and produce a high-speed stream of exhaust gases. This action will create an action force directed downwards as the rocket releases the gases at a high velocity. According to Newton's third law, the expulsion of gas creates an equal but opposite reaction force. This reaction force creates an upward thrust, also known as reaction force, resulting the rocket to launch upwards. The magnitude of this thrust force is equal to the force exerted on the expelled gas, but in the opposite direction. As the mass of the rocket is big, the force of gases expulsion must be very large so that the acceleration is high enough for the rocket to get launched into space.
Hi guys! So for the second example of Newton's third law is a shooting video. So how is a shooting video related to Newton's third law? When the rifle exerts a force of 2000 Newton on the bullet to propel it forwards, the bullet exerts an equal or opposite force of 2000 Newtons on the rifles. So this result is in the rifle experiencing a recoil force, which is a backward movement or kick felt by the shooter, as I showed you on the arrow in the video. So I have provided you a sample question for this shooting video, which is, in a shooting video, a rifle with a mass of 4 kg fires a bullet with a mass of 0.02 kg. The rifles exert a force of 2000 Newton on the bullet. According to Newton's third law, what force does the bullet exert on the rifles? And what is the resulting acceleration of the rifles? So we know that in Newton's third law, we use the formula of F equals to ma. So we want the acceleration for rifles. So we got F, which is 2000 Newton. We got mass for the rifles is 4 kg. Then we want the A. So A equals to F divided by M. And we got A equals to 2000 Newton divided by 4 kg. And the acceleration is 500 meter second squared. Thank you. Bye. Assalamualaikum.